We're now going to jump into what we call trigonometry and the introduction of the very basic trigonometric ratios. Good test of this will be your ability to say that very rapidly 3 times at the end of the 6 weeks. And if you can do that without laughing, stuttering, whatever else, we just might get you out of here and past. Now, trigonometry is made up of some Greek words, which trigon, which is triangle, metron, which is to measure, basically to measure triangles. And what we're going to do is we're going to be looking at, and first of all, we're going to start with the measurement of right triangles, and then we will eventually progress into where basically trigonometry will show that these trigonometric ratios can be used for any type of triangle. In fact, we'll come up with law of sines, law of cosines that we can use for any type of triangle, not just right triangles. These are the very basic trigonometric ratios. There are others, secants, arcsecants, cotangents, all that kind of stuff that you'll learn more about in college algebra, calculus, pre-calc, so forth, and also get into unit circles and understand those. But let's start on these and let's talk about them. Trigonometric ratios are just that. What's a ratio? Ratio is comparison of 2 quantities or 2 numbers, and that's exactly what we're going to be doing. You create a fraction or a comparison of 2 numbers. Okay, so each one of these is going to compare 2 numbers. They have a certain relationship between the things that we're going to compare. The basics of these are, we call this one the sine, S-I-N-E. Not sine A, not sine, whatever, but just sine. Just pronounce it just like you would S-I-G-N. So the sine of angle A, which guess what, is at point A, because that's a capital letter. Now you begin to understand why I was so insistent on how we name things so that you don't get confused. The sine of angle A, okay, and it is the opposite side, the measure of the opposite side divided by the hypotenuse. Some of you are going like, I have no concept what's going on. Let me try to help you. Understanding this is a new mathematical system, numbering system, based upon what you are so familiar with. We all of a sudden are looking at the measurement and the calculation methodology used by engineers, physicists, geometers all over the world for eons and ages. Okay? It has to do with angles, the relationships of those angles and triangles and right triangles, how they're related to each other, how we can find the lengths of things based upon those angles, and how far away something is from those angles. And it's a whole numbering system and scheme based upon that. Now, are you going to understand it one day? No. That's not going to happen. You have an opportunity and you have a choice. You can try to understand it all before you grasp it and use it, and that may take you a while. Or you can just say, okay, throw me in the deep water, throw me a life preserver, and I'll dog paddle and do whatever I need to so I can use it, and then one day, you know what? I'll figure out how to get rid of the life preserver, and I'll learn how to swim in this numbering system and in this methodology and in this mathematics called trigonometry. Okay? So, this can be challenging for some people. I urge you just to accept it, look at it, let it wash over you, take it, use it for what it is. Okay? Somebody named these things. Who? I don't know. They came up with these names for a reason. They have meaning. They take on their own meaning. Okay? And I would urge you to accept them. So the sine of angle A, which is the angle at point A, is a ratio of the measurement of the opposite side divided by the hypotenuse. The cosine of angle A, which is at point A, is the measurement of what we call the adjacent side divided by the hypotenuse. And we'll talk about in just a few minutes what adjacent and opposite side means in your point of view there, because it's extremely important where you are and where you're standing on that triangle as to what is opposite and adjacent. Briefly, I'll tell you, the opposite side is the side I cannot touch. If you're standing at point A, what is the side you cannot touch? It's the one over there. I can't touch it. You understand? If you're standing at point A, you're going to be able to touch the hypotenuse, grab a hold of it, and you can touch one of the legs, but you can't touch the other leg. And we'll show that in a minute. If you're standing at point A, you'll be able to touch a side, a leg, and then you'll be able to touch the hypotenuse. In fact, let's change this to right here. Let's change these to legs so that they'll make a little more sense. Okay? We're going to say this is the opposite leg, this is the adjacent leg, this is the opposite leg, and this is the adjacent leg. Okay? This is the cosine, and this is the tangent. Notice that the sine and the cosine both include the hypotenuse, and the hypotenuse is the denominator of these two. Okay? The hypotenuse is the denominator. Notice that the tangent does not include the denominator. So if we want to do calculations that do not include the does not include the hypotenuse. If we want to do calculations that do not involve the hypotenuse, you're automatically going to be drawn toward the tangent. If we want to do calculations that involve the hypotenuse, it's going to have to be the cosine or the sine, either one. Okay? Sine of angle A standing at point A is the measure of the opposite leg divided by the hypotenuse. Cosine of angle A standing at point A is the measure of the adjacent leg divided by the hypotenuse. Tangent of angle A standing at point A is the measure of the opposite leg divided by the measurement of the adjacent leg. Now, how do we write this? Sine of A. That is not pronounced sin of A. Oh, what's the sin of A? No, it's not the sin of A. It is the sine. This is a long I. The sine of A, we abbreviate angle A to just say A, so we don't have to write so much, is equal to, and we abbreviate opposite over hypotenuse. Cosine of A equals adjacent over the hypotenuse. The tangent of A equals the opposite over the adjacent. And we've come up with an even shorter way of saying this, and you have to learn how to speak Swahili, Hawaiian, whatever you want to call it, and you have to give it a little bit of attitude. This is S-O-H, C-A-H, and T-O-A, and it's done like this, Sukatoa. Okay? You got to put a little attitude in it. Sukatoa. Ready? Come on. Sukatoa. Sukatoa. Alright? Coach Smith is sitting up here going, Sukatoa to you. Alright, Sukatoa. I will tell you, I still use this. Do I remember all this? No. I remember this. What does this stand for? The sine equals S equals, let's just underline this, S equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. I still use that today. This is what I remember. This is what I go by when I'm doing trigonometric ratios. Okay? So, write it as many times as you possibly can. Sukatoa. And when you write it, remember what it is. The sine equals opposite side divided by the hypotenuse. Cosine equals the adjacent side divided by the hypotenuse. Tangent equals the opposite side divided by the adjacent side. It's an introduction to trigonometric ratios.